Welcome to my YouTube channel. In this video we are going to learn how to write mathematical equation in LaTeX. We are using Tech Studio as we have discussed in our previous videos. So let's get started. So here we are using different packages as written here, and these packages are used while writing mathematical equation. As you can see here, the required packages are AIMS math package. This is an advanced math environmental package, and this is AIMS sim package, which is additional math symbols when we are using. We are also using the package physics notation, derivatives and vectors. Another one is BM, which is used to bold math symbols. Here we are using math tools as well, which is going to load AIMS math automatically. So we are not going to use AIMS math package as it is already there in this particular math tools package. So let's understand about the math tool package. It is going to align the mathematical equation. Here we have written begin align and end align. This is going to align our mathematical equation right this way. If fx and equals to x plus 1 raised to the power 2, and we have given the line break here by using double slash, and this is our next line of equation, which is x raised to the power 2 plus 2x plus 1. If we see the output here, we can see that how beautifully it has rendered our code here. We are going to learn later how to write the mathematical equation. Here we are discussing about the packages only. Now let's understand about our next package, which is very important in writing mathematical equation. This is basically the AIMS sim package. Let's understand its usage. As we have written, the set of the real numbers is denoted by $mathbb and R. So if we see the output here, that means we are representing this R as a real number. So let's understand how this package is going to help us in writing these symbols like real numbers. See, the set of real number is denoted by R here. We can see that how beautifully the R is written in the form of the real number symbol. So this is the advantage of this particular package. Now let's understand about our next package. So our next package here is physics package. It is going to help us in writing the equation like derivative and vectors as well. Here we have written the derivative of fx is slash dv fx and x here. That means this part denotes the denominator. So if we see the output here in our output pan, then we can see that how beautifully it has written here. This is the first part where we have used the physics package, and you can see that it has shown us in the fraction form. However, we can also write this particular equation in the normal form, which is an inline form. The derivative of fx is $fraction. If we have to write fraction, then we are using this fraction d of fx upon dx. So if we are going to see the output here, then we can see that this output and this output are same here. However, the major difference is we have not used the fraction code here in this particular equation where we have used the physics package. On the other hand, if we are using the inline commands, inline code, then we have to use fraction separately to represent it in this particular form. Now let's move forward and understand our next package, the usage of the next package. So here we have our next package, which is BM package. It is basically used to bold the vectors or mathematical equation. So here we have the vector BMV is defined as slash BMV is equal to begin P matrix. This is a matrix form, and we are going to learn later how we have written this. So if we see the output here, then we can see that it has bold this particular v here, which is represented for vector itself. Also here it has bold this particular v here, and this is our output of a matrix. Now let's understand how to write a basic mathematical equation in LaTeX. This is an inline example. Einstein's famous equation is dollar. This is the mathematical environment while using the inline mathematical equation, as we have discussed here. Inline example, this is an inline example. So this is dollar, you can write it this way. You have to write this double dollar, and between these dollar you can write any equation. For example, if you have to write x raised to the power 2, then you can simply type x, and you have to press shift plus 6 number key to write this particular symbol, which is used to write raised to the power. That means if we are using x raised to the power 2, then we can use this particular symbol and write 2 here. So let's see the output here. So here we can see that E is equal to mc square, which is written before x square. So here we have our output, which is x square. Similarly, we have written this particular equation, which is E is equal to mc square. Now that was an example of an inline mathematical equation. Now let's understand about the displayed example. We have another mathematical mode, or you can say mathematical equation environment, where we are using this slash and the square bracket, or you can say the large bracket itself. So in between these two brackets, if you write any equation, for example, so in between these two brackets we have written x equals to slash fraction minus b slash pm. This is used for plus minus symbol. That means if you are going to use plus minus pm like in a quadratic equation, so we have to use slash pm. Now how to write a square root? So to write a square root, you have to use slash sqrt here, and between these bracket you have to write any equation, and that equation will be visible in the square root form. Very simple. Now in between this we have written b raised to the power 2, which is the formula to find the solution of a quadratic equation, which is b square minus 4ac and upon 2a. Here we have used slash frac. So this is basically used to write our fraction part. That means if we want to write 1 by 2, then we should write slash frac 1 upon 2 here. So this is going to give you fraction 1 by 2, that is half. Now let's see the result here. If we see the result, then you can see that this particular equation is written after this particular text. That means this is not an inline example. It is showing the result in the next row here. So this is the basic difference when you are writing any equation in double dollar symbol, and if you are writing your mathematical equation in the square bracket, that means the displayed form. Now let's understand how to write fractions and roots, which we have already discussed. To write a fraction, we can write slash frac within dollar, which is an inline mathematical mode, and fraction 3 by 4 here. Let's see the result here. Now if you see the result, then you can see that 3 by 4 is in the form of a fraction here. Similarly, how to write it in the form of a square roots, how to write the roots? So you have to write double dollar symbol, and in between this you can write slash sqrt, as we have discussed earlier. you can write 14 here, and let's see the result. Here we have already written sqrt2, and here we have written slash quad slash square root of this one. So let's understand first the basic concept, how to write the square root of any number. So here we have written square root of 14 and square root of 2. So these are the basic example how to root the square root. Now let's understand how we have written this cube root of 8. So this is also very interesting. So to write this particular form, you can simply write slash sqrt. So in Tech Studio, you are going to get two options here. One is simple square root and another one is sqrt, then it is showing root and then argument. If you are going to write this way, or you can simply enter this, then it is going to give you some option. Square root, what is the root here? That means fourth root, third root, fifth root, whatever. So let's say we are going to use fifth root here, and what is the argument? Let us say we are going to write 15. So let's see our result. We have to close this particular mathematical form as well. So let's see the result here. So here we can see that fifth root of 15 we have written, and in our previous example we have written cube root of 8. So this is how we can write the square root as well as any nth root which we have written here in the form of the fifth root of 15 here. I hope you must have understood this particular concept. Now let's move forward and discuss some more examples. Now let's understand how to write exponents and indices here. So if you are going to write raised to the power, as we have already discussed, let us say we have to write y raised to the power 3. You have to use this particular symbol and write 3 here, then close this particular bracket. Here we have used an example which is x raised to the power 2. So let's see the result here. Here you can see that x raised to the power 2 and y raised to the power 3 is written here. Now let's understand how to write underscore any number in underscore form, as we have written here. So simply you can use the double dollar symbol and write a, then use this underscore symbol, then write 1. Let's write y underscore 2, which we generally used in our second derivative test in mathematics. So let's write it this way, write underscore 2. Now use F1 key. Now let's see the result here. See, we have a1 here, as we have used here a1 a underscore 1, then we have used a underscore 2 here, and here we have used y underscore 2. You can see the difference here. The gap between a2 and y2 is not there. However, the gap here is available between a1 and a2. How? We have used this particular symbol, that is slash and semicolon here, to give a small gap here. There are a lot of methods with the help of which you can give gaps here, which we are going to discuss in our later videos. Now let's move forward and discuss some more examples. Now let's understand how to write a sigma function in LaTeX. So to write a sigma function, you have to use slash sum underscore I is equal to 1, that is, this one is your lower limit, and raised to the power n, that means summation underscore I is equal to 1, this is your lower limit, and upper limit is n here, into, that means the sigma function is basically I raised to the power 2 here. So let's see the result, how it is showing. So here we can see that sigma function, which is the lower limit I is equal to 1, and the upper limit it is showing n, and the function is I square. Similarly, how to write the integral symbol, that is how to write the integration symbols here. To write the integration symbol, you have to write simply slash int, very simple, and you have to write this in the mathematical form or mathematical mode only. So here we have written slash int, and we have used underscore for the lower limit, and you have to use these curly bracket. Always remember this. Here we are using only a, so if we remove this curly bracket, even then this is going to work for us. But if you are using two numbers here, then it is going to show you error. Let's first understand this. Integration lower limit is a and upper limit is b, and the function is x raised to the power 2 and dx. So let's see the result here. So our result is integral of lower limit is a, upper limit is b, and x square dx. Very simple. Now let's understand, if we are using two numbers here and remove this particular bracket, what is going to happen? Let us say we are using AB. AB is our lower limit and we have removed the bracket, and upper limit is B here. So let's see what will be the result. So here you can see that the function has become b raised to the power b and x square. That means it is considering this as a function, not the lower limit. That means AB is not the lower limit here. So we have to make it clear in our code what we are going to show in our result. So here we have to understand that we are considering this AB as the lower limit and not B as a function. So we have to write this in a curly bracket. Very simple. So you have to write this in a curly bracket, and for the upper limit you have to write B here, and again you can see the result. There is a difference in the result now. Now it is considering AB as the lower limit and B is again the upper limit, and function is x square only. So this is how you have to write these lower limits and upper limits in the curly bracket only. Now let's move forward and discuss some more examples. So let's understand how to write the matrices in LaTeX code. Here we are using the mathematical environment, and in between these two brackets we are using slash begin p matrix and end p matrix. Between these begin p matrix and end p matrix, we have to write how many rows and how many columns we require while writing a matrix. Here we are using a very simple example, and the matrix order is 2 by 2. That means we are using 2 rows and 2 columns only. So first element is 1, then you have to write AND, so that Latex Studio while rendering should understand that this is our second element of the second column. Very simple. Similarly, to give a break, that means after this we are saying that now we are going to start the next row. That's why we are using these two slashes. After that we have written 3 and again 4. So in this manner we have written a 2 by 2 matrix here. Now let's see the output here. So this is our first output. Here we can see the matrix is written in a 2 by 2 form. Now let's understand how to make another type of matrix form. That means how to change the bracket of a matrix, and we can write it in the square bracket form. We are using the same method, however we have to change this particular P with B only, and the rest of the code will remain same. That means begin B matrix and end B matrix, and between that you have to write your elements of the matrices. So here we have written 1 and 0, then double slash, again 0 and 1. So here we are using 2 by 2 matrix. Very simple. Now let's see the result here. So here we have our square bracket matrix. Simple. Now let's understand how to write a determinant by using this form. So simply you have to change P matrix or B matrix with V matrix. Very simple, and the rest of the code will remain same. And if you render this, you will see that a determinant is there in a 2 by 2 form. Very simple. Similarly, you can make a 4 by 4 determinant or 3 by 3 determinant, whatever you like. Now let's move forward and see some more example how to write mathematical equation in LaTeX. Now let's understand how to write a Greek letters. So Greek letters are generally frequently used in our mathematical equation like alpha, beta, gamma, etc. So in Tech Studio it is very simple. You simply write a mathematical symbol here. Now write slash ALPHA. Here you can see that it is going to show you some options. Here it is showing alpha, right? So you can simply click on this or simply do enter. After that, let us say you require beta slash BETA. Simple. Now let's render it and see the result. So here we can see that alpha beta is written here, and similarly here it is written alpha and beta, but the difference is between this first alpha and beta you can see a gap, and the gap is simply slash and semicolon, just because of this. So you can make a gap by using this code, or if you don't require the gap then you can simply write this way. Now let's move forward and discuss some more examples. Now let's understand how to write a piecewise function, which is also called conditional equations, conditional functions. So here is a function defined cases. This is the mathematical mode again. Fx equals to. So here we have to write begin cases and end cases. So once you write here slash begin cases, in Tech Studio it is going to give you option here. So here it has given you begin cases and end cases, and it is showing write your content here. So very simple. So here we have written begin cases and end cases, and here we have written our equation x square comma and slash text. What is the text here? If. So here we are guiding it that we are using the text, not a mathematical equation. So it is going to write it if what? X is greater than equal to. So if we want to write a symbol like greater than equal to, simply write GEQ or slash LEQ for less than equal to. Very simple. It is going to give you options here in the Tech Studio. That is the beauty of this Tech Studio here. So X is greater than equal to 0, then double slash, obviously to give a line break here. That's why we are using this particular backslashes. Similarly, write minus x what? And again condition, that is text if what? X is less than 0 and end cases. So let's see what is the result here while we are writing our piecewise functions. So here we can see how beautifully it has rendered this particular equation and how beautifully it has written in our tech code. So this is the beauty of tech code here. I hope you like this particular video. We are going to learn how to make tables in tech code in our next video. Till then, goodbye and take care.